So this is the foundation predicted paper written by First Class Maths. I'm going to go through this paper from start to finish, and if you've got any questions, let me know in the comments and I would be happy to help. So there's a lot of detail on this, on how the paper has been put together, but it's a lot of the content that's appeared in the previous years. So really good paper to do, great revision, and hopefully you enjoy it. So question number 1, write 562 to the nearest 100. So when we're rounding to the nearest 100, the hundreds column in this case is the 5, the next number is a 6, and we know that 5 and above rounds up and 4 and below rounds down, and because it's a 6 it's going to round up. It's closer to 600 than it is to 500, so 600 would be our answer for that one. For question number 2, we want to do a third of 60. Now when we do a fraction of a number, we divide by the bottom, and then whatever that is we're going to times by the top. So 60 divided by 3 is 20, and 20 times 1 stays the same, so that is just 20. Change 9 kilograms into grams. So for these questions, for conversions, I find it helpful to write down a fact I know is true. I know that 1 kilogram is equal to 1,000 grams. Kilo anything, the K is going to be 1,000. If I had 3K in my bank, it'd be £3,000. So kilogram is 1,000. So 9 kilograms then, we know to get from kilograms to grams, we are timesing by 1,000. So that is going to be 9,000 grams. Question number 4, write 0.7 as a percentage. So 0.7 is the same as 7 tenths, or 7 divided by 10. 0.7 is 7 divided by 10. Now that is not very helpful to us at the minute because we know that a percentage needs to be out of 100. So to make this out of 100, I'm going to times the denominator by 10. I'm also going to times the numerator by 10, and that would be 70 out of 100, so that is 70%. Great. Question number 5, here is a list of numbers. Write the numbers in order of size, start from the smallest. So with your number line, if we're going for the smallest number, if 0 is here, our negative numbers, we want to go the furthest into the negative, that's going to be the smallest number. So in this case, that's going to be -7 is our smallest. And then we're coming up to -3, and then those are the negatives dealt with. Then we've got 2, 3, 5 and 10 in the positives, and so going from smallest to biggest it's going to be -7, -3, 2, 3, 5 and 10. And always check you've got 1, 2, 3, 4, 5, 6 numbers in the question, and we've also got 1, 2, 3, 4, 5, 6 numbers in our answer, so I'm happy that I haven't missed any out. That would be a really easy mistake to do, so just double check you've got the same number of numbers afterwards. Part B, write down the probability that Rita picks a multiple of 10. She's going to take one of the numbers from at random. So we've got 6 numbers there. So the probability of taking any of these cards is going to be out of 6. How many of them are a multiple of 10? Well, multiples of 10 are numbers in the 10 times table. So 10, 20, 30, 40, 50 and so on. So which of those numbers are multiples of 10? Actually, just that one. So the probability of taking that number is 1 out of 6. There is only one number there that is a multiple of 10 out of the 6 possible numbers that we could pick from. If you thought 2 or 5 might have been, then you were probably thinking of factors. So factors of 10 are numbers that fit into 10 an exact number of times, and the 2 would be a factor of 10, 5 would be a factor of 10, 10 would be a factor of 10, but in this case they were asking for multiples, which is the 10 times table. Okay, question number 6, t times t times t. So that is going to be t cubed. So the most common incorrect answer I would see on this question would be t add t, and that is 3 lots of t. But when we're timesing, it becomes t cubed. So make sure you know the difference between these two. It is not that one in this case. And part B, I've got 3x, add 2x, add 5. So we want to think about our like terms here, and we've got 3x and 2x, which are like terms, so we can add them together and make it 5x, add 5. But this term, 5x and 5, are not like terms, so we cannot combine them to become one term. They have to stay separate, so that would be our answer, 5x, add 5. Okay, question number 7. Write down the coordinates of point A. So when we're doing coordinates, we need to remember to go along the corridor, up the stairs. X comes before Y in the alphabet, so remember we're going to do the X direction first and then Y. So starting from the origin, we are going across here to -3, that's where we're going to on the X, and then we're looking at the Y coordinate, and that's 2 up. So this is the coordinate -3, 2. Point C is the midpoint of the line AB. Write down the coordinates of C. So I'm going to use a ruler here and just connect those two up. And they're asking me what point is in the middle of that line. Now we can see that overall it's gone across 1, 2, 3, 4, 5, 6 squares and down 1, 2, 3, 4, 5, 6 squares. So if I only wanted to go halfway, I could just go across 3 and down 3 because 3 is half of 6. So if we went across 3 and we went down 3, that's going to get us halfway. And that coordinate there is going to be 0 because we don't need to go across at all from the origin, and then down to -1. So 0, -1 is the answer for the midpoint. Question number 8. A fair spinner made from a square is shown below. On the probability scale, mark with a cross the probability that the spinner lands on a number 3. So there is one section that has a 3 on it, out of 4 possible sections. So we would say the probability of landing on a 3 is one section out of 4. Now, that is a quarter, and on our number line, we can see that that would go there. For part B, on the probability scale below, mark with a cross the probability that the spinner lands on a number that is a multiple of 3. Well, multiples of 3 are numbers in the 3 times table. So I've got 3, 6, 9, 12, 15 and so on. And in fact, all of the numbers on my spinner are in the 3 times table. If they are all multiples of 3, then the chance of landing on a multiple of 3 is certain, and that would be the same as 1. You could also say it's 4 out of 4, which is 1, and so the probability of that is going to go up there at 1. It's certain that that's going to happen. A bag contains 15 counters, 8 counters are blue and the rest are yellow. A counter is taken at random from the bag. Work out the probability that the counter taken is yellow. So if there are 15 counters in the bag and 8 of them are blue, if we take that away, the rest is 7. So 8 are blue and 7 are yellow. They've told us that the rest of them are yellow. So there we go, we've got 7 yellow. What is the probability then of taking a yellow counter? Well, there are 7 yellows to take that are yellow. 7 counters to take that are yellow out of 15 altogether. Question number 9. Emma buys a new TV. She pays a deposit of £150 and then 6 equal monthly payments. The monthly payments are £40. Work out the total cost of the TV. So deposit is an amount of money that you pay on the day that you say you're going to buy it. So she's paid £150 on the day, and then she also pays £40 6 times over the next 6 months. So we're going to do 40 times by 6 to work out how much that comes to. 6 times 0 is 0, and 6 times 4 is 24. So I've got £240 from the monthly payments, and we've also got £150 that she paid on the day that she committed to buy the TV. Adding that together, in total, she has paid £390. So that must be the cost of the TV. Question number 10. Work out 3/5 divided by 2. Now, when we are adding and subtracting fractions, we need to make the denominators the same. When we're timesing, we just do the top times the top and the bottom times the bottom. And when we're dividing, we keep, change, flip. Now, divide changes to a multiply. We need to flip the 2. Now, the 2, flipping it, is also known as the reciprocal. Now 2 at the minute is 2 over 1. That is equivalent to 2. That's the same as 2. So if I want to do the reciprocal, it's inverting that, we're turning it upside down, so that becomes 1 over 2 if we're turning it upside down. So the reciprocal of 5, for example, would be 1 over 5. The reciprocal of 3 would be 1 over 3. The reciprocal of 2 over 3 would be 3 over 2. So that reciprocal is turning it upside down, so 2 becomes a half. So dividing by 2 is the same as timesing by a half. And what happens now is we can do the top number times the top number, so 3 times 1 is 3, and the bottom number times the bottom number, so 5 times 2 is 10, and that's our final answer, 3 over 10. Part B, we've got to work out 1 over 8, add 1 over 2. So give your answer as a fraction in its simplest form. Now we need to make the denominators the same. So I need to make both of these fractions have the same number on the bottom, the denominator. And we need to find a number that's in the 2 times table and the 8 times table. And the easiest one to use is going to be 8. You could use 16. As long as it's in the 8 times table and the 2 times table, it's going to be absolutely fine. You just need to think, what have I times the first fraction by to make it out of 8? Well, actually, this one we haven't times it by anything. It stayed the same. With this fraction, what have I times it by to make it out of 8? I've had to times the denominator, the bottom number, by 4. So I also need to times the top by 4. There we go. And now, because the denominators are the same, we can add them. So that is 5 out of 8. Again, can't simplify it. Question number 11. Expand the brackets. So I'm going to do x times x, which is x squared, and x times 6, which is 6x. So x squared add 6x. And that's my answer. They're not like terms, can't put them together. So that is it. Part B, factorise 2y add 10. So to factorise, we're looking for something that can go outside the bracket. These two questions are the opposite of each other. So factorise, what have these two terms here got in common? Well, they're both in the 2 times table. So I can take 2 and put it outside the bracket. 2 times what gives me 2y? Well, I would need to put a y here. And then 2 times what is going to give me 10? That needs to be positive 5. So we've done the opposite what we did in 11a, and that is going to be 2 open brackets y add 5. That's factorising. I've got a separate video and booklet. Go and have a look for that on my YouTube if you think you need more practice on that topic. Okay, question number 12. Zach has 4 meters of ribbon. He needs to cut this into shorter pieces of ribbon, each with a length of 70 centimeters. How many complete ribbons of length 70 can be cut from the 4 meter length of ribbon? So 4 meters is the same as 400 centimetres. And we're going to cut 70s off of this. So I think the easiest way to do this is just to keep counting up in 70s. If I have 70 and another 70, that is 140 centimetres. So that's 2 lengths of ribbon so far. If I add another 70, that takes me up to 210. So that's a 3rd length of ribbon. And then another 70, that takes me up to 280. That's a 4th ribbon. Add another 70 is 350. Great, so that's a 5th ribbon. Now I've only got 50 centimetres left before I hit that 400 that is the total length. And that isn't going to be enough to get another one in. So that is going to be 5 ribbons that we can have in total. And that would be my final answer for that one. How many complete ribbons? We don't really care about the extra cut-off bit. We wanted to know how many complete sections we've got, and that would be 5. Question number 13. A bookshop kept a note of how many books they sold on each weekday. The pictogram below shows the number of books sold on each day. In total, the shop sold 40 books across all 5 days. 30% of the books were sold on Monday, a quarter of the books were sold on Tuesday. Complete the pictogram. So we can see here in the key that this square represents 4 books sold. So we can see on Thursday there are 4 books there, and on Friday we've got 4 and 4, so that's 8 in total on Friday, and that's going to help us in a bit. Okay, first things first, 30% of the books were sold on Monday, and we know that 40 books were sold altogether. So we need to do 30% of 40. Now the easiest way to do that, we know that to get 10%, we take the value and divide it by 10, because 10% make up 100%. So let's divide by 10, and that would be 4. If 10% is 4, then 30% is going to be 3 of those, and that is 12. We've timesed by 3 to go from 10% to 30%. So we know that on Monday, 12 books were sold. How am I going to draw that on my pictogram? Well, this would be 4. Another 4 is 8. And another 4 is 12. So there we go. That's correct now for Monday. We put equals 12 here. You don't need to, but just helps to keep track of what you're doing. And then a quarter of the books were sold on Tuesday. So a quarter of 40. And again, we saw earlier, we're going to divide by the bottom and then times by the top. So 40 divided by 4 is 10. 10 times 1 stays 10. So 10 books were sold on Tuesday. And I'm going to draw that by doing 4 add another 4, which is 8. Now I need 2 more books. I've got 8 so far, and I need this to make 10 altogether, so 2 is going to be half of one of those squares. So it looks like that. Now we just need to work out how many are on Wednesday. We know there were 40 in total, and so far I've got 12 on Monday, 10 on Tuesday, 4 on Thursday, and 8 on Friday. So I'm going to do 12, add 10, add 8, add 4, add that up and see what we've got so far. So that's 14, carry the 1, 1 add 1 is 3. So 34 books so far, which means if we do 40, take away the 34, we're left with 6 books. So that means on Wednesday, 6 books must have been sold. And I'm going to draw that by doing one box, which we know is 4, and the extra 2 that comes from doing half a square. And then that equals 6, and all of the books that were sold adds up to 40. Question number 14. Sweets are available from 2 different shops. Each shop has a special offer. Shop A, you can get 300 grams and you get a third off the normal price of £1.80. And shop B is 400 grams and you get 20% off the normal price of £2.10. Which shop is better value for money? So this is hard to know because we're getting different amounts of sweets. So what I'm going to do firstly is let's work out the discount. And when I do this on an exam, I like to lay it out like this. It makes it really clear as an examiner for us to see your working and see where your answers are coming from. So a third off the normal price means we need to do a third of £1.80 and then take that off. Now we know to do a fraction of a number, we're going to divide by the bottom and then times our answer by the top. So £1.80 divided by 3, and I'm going to use the bus stop method for this. So 3 into 1, that doesn't fit any times, and we haven't used that 1 up, so I'm going to carry it over. How many 3's fit into 18? Well, it fits in 6 times, no remainder. And how many 3's fit into 0? It fits in 0 times. So the discount here is 60p. So I'm going to take my £1.80 and subtract the 60p discount, and that leaves us with £1.20. So in shop A, we are getting 300 grams for £1.20. And we'll come back to that in a minute. Shop B, we've got 400 grams and we get 20% off the normal price of £2.10. So we need to do 20% of £2.10 and then we can take it off. Now we saw in the previous question that if we wanted 10%, we could divide by 10. And £2.10 dividing by 10 moves all the values one place over, and that is going to be 21 pence. So 20% would be double that. We're timesing this side by 2 to get 20%, so also timesing this side by 2. And that is 42p. And that is our discount, so don't forget we need to take that off. £2.10, subtract 42p. Now when you are taking away, if the number on the bottom is bigger, we would say more on the floor, borrow from next door. So I'm going to borrow from here, make this a 0 and turn this into 10. 10 take 2 is 8. Now again, for the next column, I've got more on the floor, borrow from here, so make that a 1 and make it 10. 10 take 4 is 6 and 1 take 0 is 1. So we've got £1.68 and we get 400 grams of sweets for that. We were told that in the question at the top, that we get 400 grams and 300 grams. So it's still difficult to tell which is the best value for money, but it would be easier if we could say how much would 100 grams be in each case. Now I can do that quite easily because they're both in the 100 times table, they were both multiples of 100, so I'm going to divide this by 3. Now £1.20 divided by 3, again we can use our bus stop method for that. How many 3's fit into 1? Well, 0 times. Carry that 1 over because we haven't used it up. 3 into 12 goes 4 times and 3 into 0 goes 0 times. So 100 grams at shop A costs us 40p. In shop B, 100 grams we would get by dividing by 4. So again, let's do that bus stop method. How many 4's fit into 1? It fits in 0 whole times and we haven't used that 1 up, so carry it over. How many 4's go into 16? It fits in 4 whole times, no remainder. How many 4's fit into 8? It fits in twice. So we can see that 100 grams at shop B costs us 42 pence. And there we go. We now have two amounts that we can compare because it's 100 grams in both shop. Now don't forget we're going to lose a mark if we do not write a conclusion. So they have asked us which shop is better value for money, and we can see that 100 grams costs us less in shop A, so shop A is better value. And there we go, that would be 4 marks. Question number 15. Archie, Bella and Chris each play the same computer game. During a week, they record how many games they win, draw and lose. Archie wins 50% of his games, draws 45% of his games and loses the rest. Write as a ratio in its simplest form, Archie's wins to Archie's draws to Archie's losses. So we know that he wins 50% of the time. We know that he draws 45% of the time. But we don't know how much he loses. But we do know that the percentage would need to add up to 100% of his games. So we've got 50 add 45 so far, which is 95%. So what's left must be 5%. Now we need to write that ratio in its simplest form. So let's just get rid of the percentages. We know it's in the ratio 50 to 45 to 5. And all of those numbers are in the 5 times table. So I'm going to go ahead and divide everything by 5, because with ratios we can simplify as long as we can divide all of the parts by the same number. And that would be 10 to 9 to 1. So that would be my final answer. Really important with ratio that you check you've written it the right way round. So it was wins, draws, loses. So we're happy with the order of that. Now for Bella, Bella's wins to Bella's draws to Bella's losses is in the ratio 3 to 4 to 1. What fraction of Bella's games were wins? Well, the wins is the first number, which is 3, and it would be out of all of the parts altogether. For ratio, we can write it like this, and so we've got 3 parts in the first section, 4 parts in the second section, and 1 part here, so it is 3 out of 8. If I add these together, there are 8 parts altogether, so the fraction that she would win is 3 out of 8, or has won so far. Chris won 60% of the games that he played. Chris said, I won 60% of my games and Archie only won 50%, so I must have more wins than Archie. Is Chris correct? Well, if they played the same number of games, then yes, he would. But we don't know how many games they played. It might be that he only played 5 games and Archie might have played 100 games. So we don't know what it's out of, so we don't know who won more games in total. We only know the percentage, we don't know how many games they actually played. Okay, question number 16. Describe fully the single transformation that maps A onto B. So with transformations, you've got 4 to pick from. You've got enlargement, rotation, reflection, and translation. Enlargement is going to be if it's a bigger or smaller version of the shape. So we can see that that hasn't happened here between A and B. Rotation is when it's turned, and that looks like what this one is. Reflection, we would need a mirror line, and it would just be reflected or flipped over. That's what it would look like. And then translation is when it's in exactly the same orientation, but it's just been moved. In this case, because we can see that this shape has turned, it's going to be a rotation. So that's the first thing I'm going to say. I'm going to say it's a rotation. And we would put our tracing paper over the top, and we would put our pen in a point and spin that tracing paper and draw around the A, and then spin that tracing paper until it lands on B. In this case, I'm just going to look at this point and look at this point. The origin is normally your sensible guess. And we can see that if we went 2 to the left and 1 up, and we rotated that round, it would go like this. So it is a 90-degree turn. It was pointing up to the top. It's now pointing out to the side. It's 90 degrees. So rotation, 90 degrees. That is clockwise. It's gone from A to B. So the same direction that a clock goes in. Around the point 0, 0. So really important you say which point it has spun around, and in this case that is the origin, but much easier with tracing paper than to just try and spot it. Translate triangle C by the vector 2, -1. So label the new triangle D. Now your top number, translate is just to move a shape. The top number is left and right, positive is right and negative is left, and the bottom number is up and down. Again, positive is up and negative is down. So this is actually saying 2 to the right and then 1 down. So we're going to take C and do that movement. Now looking at C, if I want to go 2 to the right and 1 down, I can pick any point I like. I'm just going to pick this point, and I'm going to go 2 to the right and 1 down. And that point is now going to go there. So when I'm drawing the shape, I want to make sure that if this is the point I'm starting from, that is the same point from where we've got to. So that's the bottom right hand corner of the shape, and so it would go there like that, and that would be D. Question number 17. A race course is in the shape of a kite shown below. Callum starts at A, runs to B, then to C, and then to D. His average speed for the journey from A to D is 4 meters per second. He then runs from D to A to complete 1 lap of the course. His average speed for the journey from D to A is 5 meters per second. Work out how many seconds Callum takes to complete the lap of the race course. First thing I'm going to do here is write my speed, distance, time triangle. As soon as we start talking about speed, we want to remember what the calculation is. So speed, if we cover up the S, we get distance divided by time. If I would like to know the time, then I'm going to cover up the T, and I'm going to do distance divided by speed. And if I wanted to know the distance, I can cover up that and do speed multiplied by time, because they would be next to each other. So that allows you to work out anything. Now, in this case, we've got a kite, and we know that a kite is going to have the same distance here and here. So the line of symmetry is like this. So the distances on the top are going to be the same as the bottom. It's on its side. So if you think about a kite, you're normally used to seeing it in that orientation. We've got 150, 150. Those two sides are the same. And then we've got 200 and 200. But it's just been turned, rotated. And so that's why it's on its side. But those values are going to be the same on each side. So we know that from A to D, up here, here, and here, in total, that is 200, add 150, add 150, and that is 500 meters. And the average speed for the journey from A to D is 4 meters per second. So we know that the distance was 500 and the speed was 4. If I want to know how long that took, I'm going to do the distance, 500, divided by 4, and we can use our bus stop for that. So 4, how many 4s go into 5? It fits in 1 whole time with a remainder of 1. How many 4s go into 10? That fits in twice with a remainder of 2. And how many 4s go into 20? That fits in 5 times. So the time is going to be in seconds. Our speed was in meters per second and our distance was in meters, so it makes sense. All of the units have to match up, that this distance is in seconds. So A to D took 125 seconds. Okay, that's that section done. And then we also need to think about D to A. So D to A we know is 200 meters, that is the distance. And the speed, we are told, is 5 meters per second. So again, if we want to know the time it took, we're going to do distance divided by speed. And 200 divided by 5, well, 5 doesn't fit into 2. Carry that 2 over. 5 into 20 goes 4 times. And 5 into 0 is 0. So that is 40. In total, work out how many seconds it took him to complete a lap of the racecourse. We would need to add those together. So 125 add 40 is 165 seconds. There we go. Question number 18, we've got some algebra. M equals 2p minus 10. Work out the value of m when p is 2. So all we're doing here is substituting. We're changing this p to be a 2. Now remember that 2p means 2 lots of p. So now we know it's 2 lots of 2. And then we need to take away 10. So m equals 2 lots of 2, take away 10. We're just changing that p to be 2. 2 times 2 is 4. And then we're taking away 10. Now don't get this the wrong way round. If we're at 4 on a number line and we are taking away 10, we're going down, we're going to go past 0, and we would actually go 6 into the negative. So this is minus 6. And part B, work out the value of p when m is 14. So now we're changing the m to be 14. So I can write 14 equals 2p minus 10. And we're going to solve this equation. Now what we do to one side, we need to do to the other. I'm trying to get this p on its own. And again, I've got another video of just questions like this if this is something that you find difficult. We're going to start by adding 10 to both sides, and that is 24 equals 2p. And then I don't want two lots of p, I just want p on its own. So to do that, I'm going to divide this side by 2, and I also need to divide this side by 2, because what I do to one side, I also need to do to the other. So p would equal 12 in that case. Question number 19, write 24 as a product of its prime factors. So we start with 24 at the top, and we need two numbers that times together to give 24. And you can do this any way you like, we should always get the same answer. So I'm going to put 2 times 12. Any prime numbers, so your prime numbers are 2, 3, 5, 7, not 9 because that's in the 3 times table, 11, 13 and so on. Numbers that are only in the 1 times table and their own times table. So if you get to a prime number, circle it. And if the other number isn't prime, then you carry on. So 12 is 3 times 4. You could have done 2 times 6. It doesn't make a difference. Circle a number if it's prime, which 3 is. 4 is not prime because it's in the 2 times table, so we can say that's 2 times 2. Circle both of those because 2 is a prime number. And once everything is circled and you've got nowhere else to go, we would just write out all of those numbers with multiplication signs in between. So 2 times 2 times 2 times 3. Now just to double check, 2 times 2 is 4. If we times that by 2, we get 8. And if we times that by 3, we get 24. So I'm happy that that is correct and it makes the number that we started with. Now you might choose to write that as 2 cubed times 3. And if it said write your answer in index form, you would have to do that to get the final mark. In this case, either of these would be okay for the mark. So that's great. Well done if you got those. Question number 20, and we're simplifying 2p squared cubed. So to do this, everything in the bracket needs to be cubed. So we're timesing it by itself and then by that value again. So everything in the bracket is timesing by itself and then by itself again. Now 2 times 2 times 2. 2 times 2 is 4. Times that by 2 and we get 8. P squared times p squared times p squared. Well, when we times, we add the powers. So p squared times p squared times p squared is p to the power of 6. Great, there we go, that's that answer. Now it says work out the value, so that means we're going to need a number answer here rather than anything with powers, of 2 to the power of 4 times 5 squared. So what does 2 to the power of 4 mean? It means 2 times 2 times 2 times 2, and then we're timesing that by 5 squared, which means 5 times 5. Now I'm going to work these two bits out separately. So I'm going to do 2 times 2 times 2 times 2. 2 times 2 is 4. Times that by 2 we get 8. Times that by 2 we get 16. And we're timesing that by 5 times 5, which is 25. So 25 times by 16. 6 times 5 is 30, so 0 carry the 3. 6 times 2 is 12, add the 3 is 15. Now we're moving over to the 1, so I'm going to put a 0 in here because it's not actually 1, it's 10. 1 times 5 is 5, and 1 times 2 is 2. Adding that together, we have 0. 5 add 5 is 10, so 0 carry the 1, and 1 add 2 add 1 is 4. So it is 400. You might have done it a slightly different way, but however you did it, should have got 400 as your answer for that one. Question 21. Work out 7 times 10 to the power of 4 times 5 times 10 to the power of 3. Give your answer in standard form. So essentially this is 7, 0, 0, 0, 0, 70,000 times 5 times 10 to the power of 3, which is 5,000. This just means times it by 10, times it by 10, times it by 10, times it by 10. So 7 times by 10, times by 10, times by 10, times by 10, that's 70,000 and so on. We know that 7 times 5 is 35. And all of these zeros would help to make that number that many times bigger. So we've got 1, 2, 3, 4, 5, 6, 7. So actually it would times by 10 7 times and get that much bigger. Now we've got to write this number in standard form. And to write a number in standard form, it needs to be between 1 and 10. So 3.5 would be the digits that we need here. And we would times that by 10 to the power of something. Now, in this case, it's a really, really big number. We want the decimal point to be here. It's actually here. Now, it's not the decimal point that's moving, it's the numbers, but it's far easier to count the decimal point bouncing than it is to count all of those numbers moving. So 1, 2, 3, 4, 5, 6, 7, 8. 3.5 times 10 to the power of 8, and that is your answer. Now, that is quite long to write all that out. There is an easier way, and that would just be to take this. 7 times 5 is 35, and we saw in the previous question that when we times, we add the powers if the base numbers are the same. So 10 to the power of 4 times 10 to the power of 3 is 10 to the power of 7, but that is not in standard form. We need this part to be between 1 and 10. If I make it 3.5, I've made it 10 times smaller. So to keep this number the same overall, I need to make this bit 10 times bigger, so that would be 10 to the power of 8. So same answer, but a little bit less writing out. Question 22, and again really common on the non-calculator paper, is to work out an estimate for 51 times 591 divided by 28. Now when we are estimating, we round each value to one significant figure. So we're going to say this is roughly equal to 50 times 600 divided by 30. Now 5 times 6 is 30, make it 10 times bigger and 100 times bigger for each of these values here for the zeros, and then divide that by 30. Now I'm going to simplify that fraction by dividing the top by 10 and dividing the bottom by 10 and making it 3,000 over 3, and we know that 3,000 divided by 3 is 1,000, so that is our rough estimate for that answer. Question number 23. A bag contains 1p coins, 2p coins and 5p coins. The number of 1p coins to the number of 2p coins to the number of 5p coins is in the ratio 2 to 9 to 4. The total value of the 2p coins in the bag is £1 and 8p. A third of the 5p coins are removed from the bag. For each 5p coin that was removed, a 1p coin is added. Once this has been done, the total of 5p coins to the total of 1p coins is in the ratio n to 1. Find the value of n. Okay, a lot of information, so let's just start at the beginning and break this down. We know that the number of 1p coins is 2 parts, the number of 2p coins is 9 parts, 6, 7, 8, 9, and the number of 5p coins is 5 parts. So we know that however many coins are in the bag, we need to put the same number of coins on each of these piles, and that would give us the ratio of the number of coins. Now it says that the 2p's are worth £1 and 8p. So if it's worth £1 and 8p and each coin is worth 2p, if we divide that by 2, that will tell us how many 2p pieces there are. £1 and 8p divided by 2 is 54 coins. So that must be 54 2p coins. Now 2p coins was this middle section here. So I know that there are 54 coins over these lines. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. If I take 54 and I divide it over those 9 piles, it is going to be 6 coins on each pile. And that helps me out massively because I now know that if there are 6 coins on each of these piles, there are also 6 coins on each of these piles. So I now know that I have 12 1p coins, I have 54 2p coins, and I have 4 lots of 6, so 24 5p coins. Now it says a third of the 5p coins are removed from the bag. These are the 5p's over here. Let's put 5p there, 2p there, and 1p there. A third of these coins are removed. So a third of 24. Now remember we said we divide by the bottom and then times that answer by the top. 24 divided by 3 is 8. And 8 times 1 is 8. So there we go. We're going to take away 8 5p coins, and that would leave us with 16 5p coins. But then it says for every 5p coin we remove, we're going to add in a 1p coin. So that now means we've got 20 1p coins. And we still have 54 2p coins because we've not changed those. So that's how many coins we've got. Now we're being asked for the total value. So the total value of our 20 1p coins is 20p. The total value of our 54 2p coins hasn't changed, we've still got 54, it's still going to be £1 8. And the total value of our 16 5p coins, we're going to times 16 by 5, and that is 80p. Now we're asked to give the total value of 5p coins to the total value of 1p coins in the ratio n to 1. So the total value of the 5p is 80p, and the total value of the 1p is 20p. we've got to make this side 1. That's what they've asked us for in the question. They want it in the ratio n to 1. So we don't know what the left-hand side is, but we know that the right-hand side needs to become 1. We have divided this side by 20 to make it 1. And if we need to keep this ratio the same, which we do, we also want to divide this side by 20 as well, and that would be 4. So there we go. It is just 4 was the number on the left that they were looking for. 5 marks, quite a tricky question. But well done if you followed along with that one. Question number 24. Here is a rectangle and a square. The shaded shape below is formed using one of the rectangles and 2 of the squares. The perimeter of the shaded shape is equal to 54 centimetres. Show that 2x add 6y equals 54. Okay, so on these show that questions, you want to kind of ignore this. You're basically going to try and come up with that on your own using the information that they have given you. So they're talking about the perimeter, and we know that perimeter is the distance around the outside. Now I know that this is y. This is also y, and this is also y. This one is y, this one is y, and this one is y. So is this one. This one is x, we're getting that from here, and this one is y. That is the distance around the outside. Now the only bit that we haven't actually measured at the minute, or haven't got the length of, is this little bit here between the 2 squares. And the length of this bit is quite tricky. It would be x, which is the whole way across, take away a y for this bit and take away a y for this bit. So this part here actually is x take away 2y. That is how long that section is, because it was x, the whole length, the whole width of that shape, but we've taken off 2 y's because they've already been covered. Okay. So then in total, I can say that the perimeter of this shape is y add y add y, add x minus 2y, add y, add y, add y, add y, add x, add y. And that's got me all the way around the outside of this shape by adding together all those different parts. Now that equals 54 because they told us in the question that the perimeter is equal to 54. So that allows us to make an equation. And now I'm just going to collect up everything I've got. So I've got y, 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 take away 2y, add y, add y, add y, add y, add y. So there we go. 1, 2, 3. Take away 2 takes me back down to 1, 2, 3, 4, 5, 6 y's all together. Or you could say there's 8 y's, take away 2. So anyway, we've got 6y either way we look at it. And then I've got an x here and I've got an x here. So it's 2 x's, add 6 y's, and that equals 54. And now we've got what they got. So we didn't use this, we just showed that we got the same answer as them, and that's that for 2 marks. It then says the perimeter of the square is 20. So the square was y, 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 and y, and we're now being told that the perimeter of that square is 20. Well, if y add y add y add y is 20, then 4y equals 20. And that means we know that each side, if we divide by 4, y has to be 5. 5 add 5 add 5 add 5 is going to give a perimeter of 20. Once you know that y is 5, we can use this equation to work out what x is. We know that 2 lots of x add 6 lots of y equals 54. And if we now know that y is 5, we can put that in here. And this is 6 lots of 5 or 6 lots of y, so that is going to be 30. So 2x add 30 equals 54. Think about solving our equation. Again, we're going to do the same thing to both sides. So I'm going to take the 30 away to get rid of it. I'm trying to just get the x on its own. So that leaves me with 2x equals 24. And if 2 lots of x is 24, 2 lots of x is 24, I'm going to divide both sides by 2 to just get 1 lot of x, and that would be 12. And that was 5 marks. Last question, I think, for this one. Yep. Question 25. Here are the first 4 terms of an arithmetic sequence. So that means we're adding a number each time. Write down an expression in terms of n for the nth term of the sequence. So from 20 to 28, we've added 8. From 28 to 36, we've added 8. And from 36 to 44, we've added 8. So this is most like the 8 times table. So we write 8n. 8 times 1, 8 times 2, 8 times 3 would give us the 8 times table. However, this is not the 8 times table. 8n would get us 8, 16, 24, 32, and so on. It would get us the 8 times table. We're starting on 20, and the second term is 28, and that is 12 bigger. So it's the 8 times table, add an extra 12, and we write that as 8n, add 12 more. The nth term of another sequence is given by the expression 2 minus 5n. Find the 12th term of this sequence. So the reason we get an nth term is so that we can work out any number in the sequence by changing n to be the position that we want. We want the 12th number in the sequence, so we're going to change n to be 12. So that is 2 take away 5 lots of 12. So 5 times 12 is 60, and 2 take away 60 is minus 58. You're going down into the negative, starting at 2, taking away 60, so minus 58 is the 12th term of that sequence. That's the end of the paper. I hope you found it helpful. Please let me know in the comments if you've got any questions. I would love to be able to help you. Thank you so much. Bye.